Another criteria we can use to determine whether or not to reject the null hypothesis is to compare p-values and significance levels. Let's start with talking about significance levels. The significance level alpha is the probability that the test statistic will fall in the critical region. Whoops, where'd it go? There we go. That it will fall, let's start over. The significance level alpha is the probability that the test statistic will fall in the critical region when the null hypothesis is actually true. So what this is saying, this is an error, right? This is our amount of error we would expect, because sometimes we will make a mistake and our test statistic falls in the critical region. We reject the null hypothesis, but it was actually true and we shouldn't have. This reminds us of the alpha in the confidence interval estimate. Recall that alpha was the percent of confidence intervals that we could construct if we constructed several of them over using the same sample size, that percentage of them would not contain the true population parameter. We knew that that was a possibility. We're never 100% confident is the point. Remember, we would say if an alpha was 0.05, we were 95% confident because we knew there was a percent chance that we were wrong. Well, that's the same thing here with the significance level. The probability that we calculate this test statistic, it falls in the critical region, but the null hypothesis was actually true, and we shouldn't have rejected the null hypothesis. So that's our significance level. If the test statistic falls in the critical region, we're going to reject the null hypothesis. That's our criteria. So alpha is the probability of making that mistake, of rejecting the null hypothesis when it's actually true. Okay, so that's our significance level. Now let's look at the p-value. The p-value, or probability value, is the probability of getting a value of the test statistic that is at least as extreme as the one representing the sample data. So recall, you get your sample, and we did this in a previous video. I had a p-hat and I calculated a test statistic, and so this is the probability of getting a value of the test statistic that's at least as extreme as that one. So we'll go back to that example and talk about the p-value and critical value, the significance level with that example. So let's see, last time what we were talking about was a proportion, and we said the proportion was equal to 0.5. These were our that was our null hypothesis. And our alternate hypothesis was that the proportion of students who had a credit card was greater than 0.5. It said most students, right? So we had determined a test statistic using the calculation, and we had a critical value. So the critical value was 1.645, and that was based on our significance level, the alpha, right? This is with an alpha of 0.05. We had this probability here. So that's our probability that we reject the null hypothesis when it's actually true. But we also calculated a test statistic, and recall it was like 2.83, I believe. So it was out here. Well, the p-value is this area. Okay, the probability of getting a value of the test statistic that is at least as extreme. In this case, extreme means high because we're up on the right tail of the curve. So at least as high or as large as the one representing the sample data. This was the one representing the sample data. That's the one we calculated using p-hat. Okay, so this is our p-value, this area here. So even without knowing what the p-value is, you can just look at this and see that it's less than our critical value of 0.05, or our significance level. We can see that our p-value is less than that without even knowing what this area is. We know it's less than 0.05. Well, the null hypothesis is rejected, we've already said, if the test statistic falls in the critical region that is cut off here with the borderline with our critical value. But it's also another way we can determine whether or not to reject is if the p-value is less than alpha. So one way to remember that is if p is low, HO must go. And by low we mean less than or equal to 0.05. If P is high, HO will fly. In other words, we don't have a reason to reject it, we fail to reject it. Okay, so that's just a little memory trick you can use to remember this. But we can see that if our p value is less than our alpha, our test statistic will definitely be in the critical region, because that's what these areas represent. So this is our p value. So the ways we've talked about now of determining whether or not to reject the null hypothesis have to do with comparing the critical value with the test statistic. Let me mark those. So this is test statistic, and this one is our critical value. Or to compare the p-value with our alpha, our significance level, and use this handy memory trick.